Hi everyone. So today we will look at the exe file format. We will look at the exe file formats. Yeah. So the exe file format is the other nameless format of DOS because again, in those times, oh yeah. So first of things first, I will again use a lot of pictures that are from my GitHub Korkami Pics repository. So just that you know that most these pictures are free. Yeah, so from the official Microsoft MS-DOS programmers reference, MS-DOS recognized two program types: COM and exe, and COM and exe, a COM program and an exe program. So again, the exe format, that exe format is called the exe program format. It doesn't even have an official name. Okay, and this was the first executable that the first exe that I know of is used in IBM PC-DOS in its link.exe and IBM PC-DOS. So it was done by Microsoft for IBM, unless I'm wrong. And it was, yeah, it's from 81, so not exactly new. And that's the first MZ executable. So why I say MZ? This is because of the magic signature. We will see that soon. So now, yeah, so what's next? So just for it's a fairly simple format and just a single header with a signature at the beginning. And just for the reference, of page in this case is 512 byte and a paragraph is 16 bytes, so a single line of hex. And we will start. So oh yeah, if you don't know, maybe you're very actually if you look at malware, maybe you've seen a lot of these how do you say do or is it this part of the PE executable. If you remove this part here, then this is an executable at the start of the P. So let's go the other way around, but at least this is something that you have maybe, yeah. But instead, so that out of that, so, I mean, I made an illustration out of the standard stub that I just showed, that is seen in most executables, most P executables. So P being portable executable, being the Windows ones, and then otherwise this is actual DOS executable. From this is actually the link .exe 1.0, and we'll see a few differences, but altogether it's a very easy format. So basically it just has a magic, just has a header at offset 0, and this header is a constant size. And what is important is that it starts with the magic from the author of this format, most likely. I mean, I don't know if he designed or if he co-created, or I mean, Marks Bikowski and Zibo, also called Zibo colloquially. And yeah, so then so with the notion of pages that we mentioned before, it has this weird situation where it defines the file size with the next two parameters, which are words. I mean, at the time, not many things have double words. You know, it's 16-bit assembly. So yeah, AX is your biggest register, right? No EAX yet in computer history. I mean, not on DOS at least. And so you have two numbers: the number of pages and the last page size. So basically, you multiply the second number to tell the amount of page that you require for the whole executable, but you also in the last page you only take the amount of bytes that is specified in the first element. So basically this gives you as well the size to allocate, and also where the executable stops and basically where the overlay starts. I have here, where is it? I have here an zip executable, and we will see that. So the page in file, so it's 19 pages, so 19 times 512 in hex, so 200. And and but in the last page only take 1 EF bytes. So basically it means that if we calculate, it's like we only need 18 page, multiply by 512, so 512 plus 1 EF, and that gives us 1 EF, which would be the size, the where the executable stops and when the overlay starts. And I'm showing this because it's a zip auto extractable MZ executable. And so indeed we jump at 1 EF by going to go overlay, so the computation is correct. But we see that indeed there is and there's a 7, which is a beep, and then there is overlay. So that's the appended data compared to the original file. It has its importance later because there is one parameter that I have never been seen used. I mean, I don't remember seeing used. Anyway, we'll see that later. So that's for our zip file. And now look, let's go back. So we have the head or the reloc count. The relocation thing is happening with two parameters that look a bit distinct from each other. The reloc tape pointer at offset 18 is 1C, which tells you where the relocation table starts, and the relocation count, the one at offset 6. So let's do that on the actual file. So the relocation table address tells us where the relocation table starts on the as an absolute offset in the file, and then the relocation count tells us how many relocations are there. So yeah, and so here we see that there's none. And yeah, so it's weird that these two values are separated. Okay. Then paragraphs in header. So this is just to tell us that the header in this file is 6 paragraphs, which means again six. So it's easy. 6 lines, 6 times 16 of hex. Okay. So in our case, the header size here is A0. So basically, the header is this one has a huge relocation count. Actually, I'll open it. This is link.exe, link that one, I think. And I see that it has a lot. All this is definitely a repetitive pattern, you know. This definitely looks like a relocation table. And yeah, so basically so relocation count 207 of them, 512, 19, 519 in decimal, and the relocation table address starts at 1C. So 1C is here, and then all this each relocation is 4 bytes, as we can see. Each relocation is 4 bytes, and we see that it's a long relocation table, and basically this is why the header is so big, of being A0 paragraphs. So it's easy, shift 10 more to go in hex, and that gives you A00. That's the end of the that's weird. A00. Did I do something wrong? Okay. Oh yeah. Okay. Okay, that's weird. A00. Okay. Feels like I'm doing something wrong. No suggestions. A00. A00. Yeah, okay. That's a bit weird. I would assume the code to start directly here. That's weird. Typically, when you look at the binary and you just multiply the paragraphs header, so 200 in this case, and you see right after. So I don't know if you had the time to see. There are 20 paragraphs, so 200 bytes of header, and right after 200 bytes, this is a binary from DOS 2.0, but this other one was from 1.0. So maybe they had, I don't know. But this is weird that for 1.0 there is so much free space, you know. Maybe there's another restriction. I don't know. This is weird. Now that I think of it, because at the time I'm not even sure floppies of 360 kilobyte were a thing. I wouldn't be surprised if it's not the case. I don't remember the files, the the storage space of such hardware. Anyway, so okay, now we've seen that, as you see, there's not so many things. So now you have two parameters, which is the minimum allocation parameter, and max is 0 for some reason. Okay, that's surprising, because on stubs, usually, okay, I'm gonna open on stubs. It's, as you would imagine, FF as a maximum. Then those two, the IP, the CSIP and the SSSP, are just the initialization segments and registers for the stack and the position. It was at the time of segments. And then there's a checksum. I'm not even sure if the checksum is important. Let's see. There is this stuff with the nodes. Checksum, complemented checksum, a word checksum. This value is rarely checked. Okay. Okay, I don't think it's so important. You can see in the PE header, it's set to 0. In the stub of a PE header, it's set to 0. So as you can see, it's a very simple, it's a very small structure. Not much to say from the actual MZ executable structure. And then there is, of course, as mentioned before, the relocation table. And yeah, then that's pretty easy. Oh yeah, and there is the entry point, which gives you where the entry point is. So this is an absolute entry point in the file. So yeah, as you saw, maybe I was too fast. The entry point, where is it? Oh, it's not this. Oh, it shows it here. New exit offset. Okay, this. So it's funny here. We see maybe you see the problem, but yeah, it's because this new entry. Okay, this is weird. Okay, um, see, the entry point is indeed uh wait, oh yeah, no, sorry, the entry point is calculated with the CSIP. Okay, sorry. Okay, so first things first. First things first. Already covered a few things, right? So I showed you the zip auto extractable, which has some overlay, and yet very often. So after this relocation table pointer, there is this that is called the overlay number at offset 1A, and I don't know. I've never seen it used, even though it's supposed to be used for programs that have overlay. And in the case of my zip file, well, it doesn't. So that was I was expecting, because this program has um, an overlay. Then I was expecting this value to be set, but no, it's still not set. And then that's the end of a standard executable header, the original DOS header executable. Now, one thing is that, is it MZ? You would say yes, of course, Mark Zivotski, but it was done by, you saw, it's not MS-DOS. It was done by Microsoft for IBM, and IBM was using a lot of Bingenian stuff, and they created actually they create MS-DOS 1.0 didn't check the signature at all, even 1.25. So let's see that. The source is online, right? And in 1.25, it's just checking for the extension, and it's not checking for any signature. And then if you see the source of 2.0, then it's still Zibo arises. It still checks if there is a signature or an old signature, and the old signature is ZM. Okay, where is it? Old. Can I get? No. Can I get? Give me this. Search for this symbol. Will it go? Oh, so okay. Sign in. Yeah, thank you, GitHub. Okay. So basically it's ZM, and that's big at the time. They did a few blog posts actually explain that for IBM Pascal 1.0, which was supplied by on PC DOS one. I mean, with the first computers, then they did they wrote the signature the big endian way, and therefore they are executables that start with ZM, and it still works. I mean, it still it can work. I actually had created my own ZM. No, did I? I think I thought I did. Oh yeah, that's one. This one was working. This is a executable that I did myself, and it was working under Windows XP. It was still working under Windows XP. So uh, you see, this is me just abusing the format a bit more. There is actual code here, and yeah, that's with the ZM signature, and it works. What else? Um, Actually, I was jumping over the signature, because why not? Over the string. Okay. So indeed, in the past, there was ZM as a signature for DOS executable. Of course, it's not the case for format for exe-based format like PE, but yeah, in the past, it was another thing. It was possible. Now, as I just mentioned that a couple of times, there are other formats that were evolved from the MZ format that you certainly know, like the PE format. And let's see, there are actually probably more than you think. And there's the MZ and the ZM. So here you have the address. The new executable is the one for Windows NT and Windows which one? Windows 3 at least. And then there was the ones for LE and LINK.EXE for the drivers of Windows 95, and we W3 and W4 were the boot software of Windows to load. So to Windows between the DOS and the functional Windows, because again, these versions of Windows were not fully an OS, but they were actually booting from DOS. You could run Win from that, or you could boot to DOS. And of course PE, which is the one you probably know the most, and then those that I don't even know. And one funny thing is that a typical question is that who cares nowadays? You would say that only P is important anymore. And I said before, I worked on AI filtering of file formats, and if I show you a header like this, then what is specific? I mean, this would look like a PE file, you would think. I mean, okay, I remove the P signature and so on, but if on the other hand I look at this, then if you see exactly the same stuff. It looks like a PE file, but if you follow the pointer to 80, I don't. So then there is a new executable file. So yeah, I forgot to mention the way it works is that these new formats are based on the actual DOS header. Then there is possibly actual DOS code, but they extended the format so basically the DOS header stops around here, and then this is unused. This is reserved, but as far as I know, it's never actually parsed by anything. I mean, except file infectors, but by official software, I meant. And then at offset 3C, there is a pointer which will point to a new header. And if one of these new headers has one of these signatures, LE, NE, and so on. So just to show you a few, that's an LE format, so an S2 linear executable. So you have the MZ header, and then you have a pointer, and at 80, then there is a LX magic, that's a linear executable. And then I did a poster for that. Then a bit similar, you have the new executable, which points to, there's a pointer. The pointer can have very different values and so on. Here you see that the message in the middle is, this is a Windows 16-bit executable. It's a slightly different. This is an OS2 32-bit executable. And then you have, it points to NE signature, NE something something, not NE00 if you notice, because the P signature is P/0/0, and it's a new executable. So that defines that. Then there is a new structure pointed at offset 3C from a DOS header. Okay, no question. So now you see that, so you see that the value that is at offset 3C is actually a pointer to something that should be usually nowadays a PE, and if not in the past, LE, LX, NE, and so on. But as I showed before, NE is actually still used by modern Windows because it's used for those graphic fonts, by these pixel fonts. If you see the font, I don't know if you see the title, modern.font, these .fon files, they are bitmap fonts, and they are still not only standard on the system, but they also have a very old copyright, and that's still used. That's the font used in the prompt. So basically, when you do properties and you do these fonts, then these ones that have how do you say, that have no, how do you say, can I just read here? No, can I? Yeah, the raster fonts, the one, no, that's the set. The raster fonts will be the one that are just used, that are just bitmap fonts, and these are still stored in new executables. So not only this is a 16-bit format from long ago, like, but the copyright is super old, and if you, as you see, Windows is still parsing the properties of this format. And yeah, copyright Microsoft 94, 85, what I'm saying. So it's pretty, not only it's funny that actually there's this presence of very old files in modern Windows, but even worse is that the header is actually quite similar because of the whole structure based on MZ to PE files, and it creates a lot of false positive from an AI perspective if you're not cautious about this corner case. But this is a corner case that is standard in Windows. So you see the file itself is from 91, 92, and the content, the resource of the font inside the file is from 85. So like, and this is still in modern Windows. So, and the font is called modern, so like very modern. And of course, there are many more in the system. Copyright 84. Wow. So basically, this older structure of MZ, then something, but it's not a PE, is also present in Windows with something that is not a PE, and for whatever reason, they kept it that way. Okay. But if you noticed, then this offset to the new header is at offset 3C. But if you realize that in all the formats, before this was a thing, then nothing was actually preventing you. Why would you waste so much space? And this is again LINK.EXE. And if you remember, the relocation table is at offset 1C. So here, and there is, yes, there is something at offset. They don't care about whatever was at offset 3C, or they don't care that in the modern version of the MZ header, this should be is usually set to 0. So again, the MZ format has slightly changed, that in the past, they didn't care about anything beyond offset 1A, 1B, sorry. And but here you see that Hugh is just thinking, hey, there's a pointer set at offset 3C, but no, it's not. It's just a DOS. It's just a table, an entry in the relocation table. So you see that it's not because there is something set at offset 3C and you start with MZ that it's definitely, first it could be any file or a new executable file, but also it could be a DOS file or whatever, you know. When you look at the whole landscape of files, yeah, some problem arise. But of course, if it's just a PE, yeah, you just follow the pointer and just expect the this is Notepad, and you follow the pointer, and you just expect that there's a P signature. Oops, there's just a P00 signature at that offset. Okay. No questions. So that's it for the change in the meaning of the offset 3C and the difference between the original DOS header and the newer PE header, the newer use in the PE header. And now nowadays, again, most PEs will be like, that's my notepad. This is just a small stub, and it's just a very small interruption. So this is interruption 21 with AH set to 9, which is print string, and then this is interruption 21 with AH set to 04, 4C, sorry, which is terminate process. So basically, this just shows, this just display the string and finish and terminate the execution. So a very simple use case. This was made so that if people in the time of when Windows was still new and not even a standalone OS, then if you accidentally run an executable, it will not crash the system or anything, but it will still display something, which is exactly why in the previous version you have, this is a Windows, this is a typo, this is a Windows 16-bit, this is a typo, this is a Windows 16-bit executable, or this is wow, this is really an OS 32-bit executable. Okay, that's weird. Did I do this mistake, or this is okay? Never mind. But nothing prevents you actually to have an actual stub, and regedit, the registry editor in the Windows 95 version, is famous for having an actual stub, an actual payload. And so it's a dual executable, and it's a legitimate one by Microsoft. So this is the header, and it's as you will see, it will make sense immediately. You see that it has abilities to import and export registry files to and from the registry, as it says. So regedit is one of these rare official file with an actual stub, a working stub in both language, because again, it's a GUI, it's a standard GUI program under Windows. And actually, does it run on my machine? No, it doesn't, because maybe it's too old. Okay, but and of course, if you, so it has an actual payload as a DOS file. Come on. It has an actual payload as a DOS file, and as you can see, it's normal assembly 16-bit. I mean, it looks like normal assembly. Trust me on that. It doesn't look like too corrupted. And if you view it from a PE perspective, then you have the familiar API calls and get module handle and so on. So regedit is an example, and a true example, that Windows and that executables can have, I mean, the exe file can be simultaneously an actual true DOS program that can have a DOS payload and a PE payload in the same file, not just a stupid stub. So, and Windows is ready for that. And actually, and then I challenged Robert Chow. So in Doom, oh, sorry, where is it? GitHub. Yeah, so Robert Chow, that's his name, I believe. Yeah, Robert Chow. So here, he made basically a universal Doom binary, and not only that, but he did that with just taking the actual binaries from the official Doom and the official a version, a Windows version of Chocolate Doom, and this is exactly what it's about. This is how it looks like as a true and here I am under, and this is the same executable running as, I mean, the same executable running as a DOS payload and a PE payload from the same file. So basically, it's just we knew that PE could also be a DOS file, but Robert proved that it's possible to do that with just any payload, because uh, he didn't just do that with heavily reconstructions. He basically just merged the file, and actually he provides the script on his GitHub, and yeah, it's self-explanatory. Everything is documented, and he just rebuilds this thing. He just merged the stuff, and basically he just ended up the from the too many windows open now, too many dooms playing. And now from his repo, then he actually took the Doom shareware, the DOS executable. He took a Doom chocolate Doom and just his script. So basically, it's not specific to anything Doom. And oh, he added a link to my pick. Yeah, okay. And yes, I documented that because it was interesting stuff. That's the structure of his file. So you have the MZ header, but then you have also the P header that is put further in the file. And because not only it's not just a P file, I mean a DOS, not just a DOS file, but it's also a DOS4 GW runtime executable, which has its specific. There are all other stuff in there is a DOS extender header, so it's not just a P and a DOS file like the regedit one would be, but it's a DOS extender file, which means it has even extra structure that were definitely worth documenting. And then I saw this ultimate Doom, and I was like, so there is a P structure. Oh, there is a how do you say, go header. There is a P header. There is a MZ header. But oh yeah, if you noticed, maybe that wasn't clear, but there is still a little room, because again, between 3C, this is the pointer to the P header, and here there was before a relocation table, as you would imagine, but obviously he had to move it away so that it still works, and that's and in the end, as I hinted before, basically between this and that you have some free space. And what happens when your Ange Albertini, there is some free space that is still available, and someone just released a Doom PDF a few a few weeks ago. I thought I have to create that, and yes, so basically I just started the usual way, I would say my usual way, to put person PDF and the signature, and then start an object and so on. But the problem is that if you notice, we are still we have very little space. And if you do, let's show you. If you do the whole person PDF 1.5, then 0D, 0D or 0A, and then you do the Doom PDF, I think had like 5 objects. So if I just 50 obj, and then 0A, and then you do a stream 0A, then I try that. And of course, after the end of the file, you need to provide first, at the end of the file, you will do 0A end stream, and then end object, and then you put the actual content of the PDF. But when I did that, the problem was that it didn't let's see, where's my Doom PDF. So basically you just end up concatenating the whole content of the PDF after the end of the fake Doom executable object. And then my initial strategy, as usual, was to remove the Xref entirely, And but the problem is that when I did that, the file didn't work as a PDF because maybe if you recall, here I didn't have the room to put a length declaration, and maybe it was like, oh, the object is so long that it cannot find the actual first object which was linked by the trailer. So basically, the software would have problem to how can I say to the PDF viewer has problems to locate the actual objects because there's no length for the stream, and the object stream containing the whole Doom dual executable is too long. So what I ended up doing, where is it? Is it here? Where are you, Universal Doom? Is it here? Yes, I just used a small script. So basically, again, the problem is that you wouldn't have any. Oh, too many windows open. The problem is that you don't have enough room to declare a length for the stream. So I was like, maybe I'm lucky, and if I just actually create a valid xref for the for this crazy binary, then it will work. And again, generating an xref and the offsets is very easy. You just need to locate the initial signature, then to locate where each declaration of an object is, and then you just fill that um, in a file. And this is what I did, and indeed it worked. So now this is the same Doom dual executable. The pointer to the P header is still at 1 AC. So this value here. The DOS header is unmodified because sorry, I modified it before I modified it before. I mean, I didn't destroy it with my PDF signature. So now I'm declaring a PDF. I'm declaring object 5. I'm declaring a stream. Then I jump to end stream. And then there is the other objects of the PDF. And I just had to, the rest is the actual Doom PDF. And then at the end, I just use my script to create an actual xref table, which has a funny look. If you see, the sizes are big, and is just the first object containing all the Doom thing that is very early in the file. And this file actually works. So I'm very I'm very happy that it works. So this is a file that works as a Doom under DOS, that works as Doom no sound. And now if I copy it as PDF, and it's under Chrome, of course, then hopefully it runs. At least if it doesn't run, it should fail already. What I mean is that usually it fails after a few seconds, after less than 1 second, it tells you that, oh, can you not resize? Oh yeah, let's resize the PDF. So yeah, what I meant is that this file is actually, if it fails as a PDF, then it's how can I say? See, I want to go to the menu. Yeah, sorry, I'm disturbed with all this Doom activity. So yes, this is a valid executable, a valid file that is a valid DOS file, a valid Windows executable, and a valid PDF. And all of these payloads are running Doom in a PDF under DOS, and in native Windows. That's awesome. And what I want to say, what else did I want to say? Sorry, but is your Python your main programming language? I'm not sure that's related. Oh, this script was pretty ugly earlier. If that's your question, I just wanted something that generates um, the offset table, not by hand. Something quick. Um, I forgot what I would say, because again, I'm amazed by having all the free versions of Doom running in this version. So basically, it's a proof that you can have executables running in three different things. It's awesome. Sorry. Once again, Doom, a single binary running Doom under DOS, under Windows, which means all the Microsoft OSs since the 80s until now, and also a Doom PDF running Doom in Chrome. Yeah, I wanted to say something else, but I think that's all. I'm happy having created this crazy PDF. It's a mix of crazy files by the already, and to make an even crazier file. So yeah, now what I said earlier is that if the file is actually if you corrupt the, let's put it that way. Yeah, this was when I wanted to show you when you have a Doom executable, like it's the same thing, but no, let's stop all those Dooms. So when you don't have the xref is not valid, it cannot find the file, and the error coming pretty early. That's another version of the file. Oh, it works. Okay, sorry, you must have done. Oh, this one has an xref. Okay, it's not the file I wanted to show you. Broken.exe. Okay, this one doesn't have an xref, and this one, yeah, this one is broken.exe, and you see the error comes pretty early. What? Oh no, I broke the exe. Okay, sorry. Okay, never mind. I cannot find my file anymore. Yeah, but what I meant is that if there is not xref table, then it doesn't know how to locate it. Maybe it takes too long to actually find the the actual PDF object without the length of the first stream object and a valid xref. Therefore, it gives up parsing the file any further, and it fails to load. What about recording game reversing videos? No, I'm not so interested in that. Q&A. Okay, so I hope you had a good time. We covered many aspects of executables in ways that I didn't plan initially. Just having running Doom and PDF and so on. That was fun, and I hope you had fun too. Hope you learned something at the time that where executables were not using an MZ signature, at the time where the offset 3C could have a different meaning and be set. So you see that there is some historical background behind the MZ format, and even in the old fonts, the modern fonts that we still use in modern OS, in modern Windows. Copyright 84, 85 from a file from 92. 92 is Windows NT, so it indeed it's correct timing with the new executable format. So yeah, old stuff. Okay, so thanks for your attention. I hope you have a good time, and more than ingestion is using the primers and one stream. Okay, I have no idea. I have a weird error at the top of my stream, but yeah. So thank you for your attention. I hope you had a good time, and see you next stream. Thank you. Bye bye.